The speed of light is the speed at which light travels. The speed of light in a vacuum is a constant value, which is denoted by the letter c and is defined as exactly 299,792,458 meters per second. Visible light, other electromagnetic radiation, gravitational waves, and other massless particles travel at the speed of light. Matter that has mass can approach the speed of light, but it never reaches it. Is it possible to exceed the speed of light? Interesting question. The researchers were able to do this with the help of pulses inside a hot plasma. Let's get to the bottom of it. Floating through the vacuum, a photon of light moves at about 300,000 kilometers per second. That's the limit of the rate of transmission of information in the universe. Is it possible to exceed the speed of light? The speed of light is the magnitude with which light moves in a vacuum. And the faster something moves, the more massive it becomes, and the more time slows down. At low speeds, it's almost undetectable, but as you get closer to the speed of light, you can see it sharply. It turns out that if you want to accelerate at least one electron to light speed, you need an infinite amount of energy as the electron becomes infinitely heavy. And light does not have mass, so it does not have such a problem. This is the difficulty of overcoming. So can we exceed the speed of light? No. Under normal conditions, we cannot exceed the limit of light, because infinite energy cannot be reached. Light has certain features that allow you to break the rules. It won't speed up the journey to the stars, but it will help create a whole new class of lasers. Physicists have long experimented with limiting the speed of light pulses, accelerating them, and even slowing them down. Various materials are used, such as cold atomic gases, refractive crystals, and optical fibers. Researchers at Lawrence's Livermore National Laboratory in California and the University of Rochester in New York City once selected a cloud of hot, charged particles, and they've been able to change the velocity of light waves in plasma from about 1/10 of the normal velocity of light in a vacuum to a velocity greater than 30%. Photon pulses can collide to create waves. Light waves pass through matter at a rate described by researchers as a group velocity, and it was this wave scientists controlled by changing electromagnetic conditions. By extracting electrons from the hydrogen and helium ion flux with a laser, researchers were able to change the group velocity of light pulses sent through the plasma of the second light source. From a practical point of view, the experiment is important not for interstellar flights, but for lasers, and will create a new, incredibly powerful generation of these devices. Lasers use solid-state optical materials, which are usually damaged at high energies. The use of plasma streams to change light characteristics would solve this problem. Thank you for watching this video to the end. Don't forget to like and subscribe to the channel to learn more about space.